Hello viewers, welcome to r22 YouTube channel. Today's topic is probability. In that we have sample space concept, events, types of events, counting sample points, problems, probability of an event, and additive event concepts, conditional probability, independence concept, and product rule, multiplication rule, Bayes theorem or Bayes rule, random variables, probability distribution, concept of a random variable, discrete probability distribution, and continuous probability distribution. Continuous probability distribution and discrete probability distribution are random variable types. You can learn part A or part B, then you will score 10 marks, a long question. By covering all these concepts, you will get 10 marks, or by practicing all these concepts, you will get 10 marks. And 2 marks, they will ask one. In these topics, they will ask 1 mark question 1. In this, they will ask 1 mark question 1. By practicing any one topic, you will get 11 marks. Probability, it is the ratio of expected outcomes from the sample space. It is the process of calculating the expected outcomes from the whole number of outcomes is known as probability. Number of occurring events for the favorable outcomes is known as probability. May or may not occur is known as a probability. Sample space, it is the set of all possible outcomes. Event, it is a process of sample space subset. Experiment, it is the operation for producing well-defined results or outcomes. Trial, it is the process of performing an experiment. The number of times is known as number of trials. Types of experiment, we have two types: deterministic experiment, random experiment. Deterministic experiment, we have exact result, like a sum of two numbers and subtraction of two numbers, multiplication of two numbers, we will get exact result, is known as deterministic experiment concept. Random experiment, it results like unexpected result, unexpected outcome. We cannot guess the output or a result, like a rolling a die. We cannot say 1 or 2 or 3. We have 6 phases, so we cannot guess the correct one. Drawing a card, we have 52 deck of cards, in that we cannot guess the exact card, so it is the unexpected result. Tossing a coin, we have two phases, head and tail. We cannot guess the correct outcome. So these are the two types of events. It is a subset of sample space. Sample space is the total number of outcomes calculation. For example, we are doing an experiment like rolling a die. We have 6 phases for die. So we will call it as 6 power n. So for 2 dice we have 36 phases. So 36 types of outcomes is known as a sample space. A number of possible outcomes or number of possible events is known as a sample space. That subset is known as an event. Performing an experiment, getting the same number of 2 dice. So for calculating number of 2 dice probability is 36. For in the 36 we have same number of 2 dice. So 1 is the one possibility, 2 is the one possibility, 3 4 5 6 6. We have 36 possibilities. In that we have same number of 2 dice, means coming same for first one and second one dice. 1 2 2 3 3 4 4 5 5 6 6. These are the 6 possibilities. These are the favorable outcomes, and the possible outcomes are 36. Probability finding formula is number of favorable outcomes by total sample space or possible outcomes. Calculation is known as probability. For calculating, here we have 6 favorable outcomes. 6 favorable outcomes by total number of outcomes is 36. By calculating, we will get 0.17. You can write like this direct answer, or you can cut it in possible ways. In any way, you will get the answer. You will get good marks. Like that, this is a process of calculating probability. We have types of events. There are three types: simple event, mutually exclusive, exhaustive. Simple event is the name itself explains about the event. It will give simple possible outcomes of an experiment. Like a coin, we have head and tail. So these are the two simple events. For the experiment or for the event tossing a coin, drawing a card, we have 52 deck of cards. In that we are taking one card is known as a queen. That is one possibility. It is a simple event, mutually exclusive event. It is also known as intersection concept. We will take two events that common elements is known as intersection. Calculating intersection or common points is known as mutually exclusive event. Two events are called a mutually exclusive event if they cannot occur at same time. In other words, it explains the event for the occurring different time for the different events is known as mutually exclusive event. For example, two events are called mutually exclusive event if they satisfying this condition cannot occur at same time. This is the main important headline for this concept. S is the sample space. We have 5 events, 5 possibilities in an event. A is the possibility of even numbers. B is the possibility of odd number. For sample space 5 elements, we have 2 and 4 are the event A. Those are even numbers. 1, 3, 5. These 3 are odd numbers. It comes to B. When we calculating mutually exclusive event, taking intersection between these two, it should be pi. After this condition is satisfied, then it is called a mutually exclusive event. If the condition is not satisfied, that is no possibility of a mutually exclusive event. When we are taking intersection, we have no common points, so we will write it as A intersection B equals to pi or null. It is nothing but no elements are common in these two sets is known as mutually exclusive event. It is the concept opposite to mutually exclusive event concept. Exhaustive event calculates the union concept, taking common terms from the two subsets or two events is known as exhaustive event. Events are said to be exhaustive events when their totally includes all the possible outcomes of an experiment. Taking union is known as a exhaustive event. If S is the sample space, we have 5 elements. E1 is the event of even numbers. E2 is the event of odd numbers. From 1 to 5, we have 2 and 4 are the even numbers. 1, 3, 5 are 3 are the odd numbers from the sample space. Calculating these two concepts is must be equal to sample space is known as the condition for exhaustive event. Even union E2 combining is known as union. 1, 2, 3, 4, 5. These are the 5 elements. Taking union for these two events and it also equals to sample space. So this condition is satisfied, then it is called as a exhaustive event. It is a condition taking two events union equals to sample space. Union of two events is must be equal to sample space is known as a exhaustive event. Another concept, counting sample points. We have 5 methods: listing method, multiplication rule, also known as a fundamental principle of counting, permutation rule, combination rule, tree diagram method. These are the 5 methods included in counting sample points concept. Listing method, It is the process of writing all possible outcomes. Useful when the sample space is small. It is used when the sample space is small. In that cases, we use this concept for counting the sample points. Tossing a coin, we have two possibilities, head and tail. These are the two events which comes to sample space. So it is a small sample space concept. So we will use it as a listing method in counting sample. It is suitable for small sample space topics. Multiplication rule. It is also known as a product rule. It is also known as another name fundamental principle of counting. We will take two events. M is the one event, N is the another event. By calculating these two multiplication together gives the result. Is known as a multiplication rule. If one experiment has M outcomes and other has N outcomes, then probability together have M cross N outcomes is known as multiplication rule. It is important for 1 mark question, and they will ask product rule theorem or multiplication rule theorem. It is also important for long question. Definition and example is important for short question. Tossing two coins. We have two coins. In that we have two possibilities, head and tail for coins. So 2 into 2 is 4. Sample space equals to head, two heads, two tails, one head, one tail, one tail, one head. These are the sample points for calculating. Counting sample points. It is the second method in counting sample points. Now we are going to discuss third type, permutation rule. It is the third type of counting sample points concept. We will use permutation concept for arrangements of objects. Part of arrangement concepts purpose. Arranging objects or books, things. For that purpose, counting purpose, we use this concept. Permutation rule. It is a rule is used for counting the sample points. It is the third method for calculating the counting points. We use it in arranging the objects purpose like books, pens, and other objects purpose. We use this formula. Permutation of n is the number of elements, r is the number of ways for choosing the object for arranging is equals to n factorial by n minus r factorial. It is a formula includes with factorial term. It is a representation with an exclamatory mark. For example, 5 factorial means it will take 5 to 1 multiplication. 5 into 4 into n into n minus 1, n minus 1. 4 minus 1 is 3, up to so on 2. After that 1. Calculating the given term to 1 multiplication values. 5 4 is 20, 23 is 60, 62 is 120, 120 into 1 is 120. Like that, calculating in factorial. 5 factorial 120. Like this number of ways for calculating purpose, we use this factorial term n factorial by n minus r factorial. By calculating this formula, we will get the number of ways where the object is arranged. Arranging 3 books out of 5. Here big term n is the big term, r is the small term. Big term always indicates as a n. Small term indicates a number of ways of arranging that is chosen. 3 ways. Total number of books is 5. In that we are choosing the 3 books. So n factorial by n minus r factorial. 5 minus 3 is 2 factorial. Calculating 120 by 2 is 60. So this is the formula we use in these books arranging purpose, and for other arranging objects purpose this formula is used. Combination rule. We have this formula which includes C term combination of arranging with some difference in modification in denominator in formula purpose. For permutation there is no r factorial. For combination we will include r factorial term. we will use it in cards purpose. Choosing two cards, so choosing it is the R term. N is equals to largest term or a big number. N is the number of cards. In that we are choosing two cards. So 2 is the R value. N is the 4 value. 4. Combination of 4 and 2 is equals to 4 factorial by 4 minus 2 factorial into 2 factorial. We can calculate it by calculating in calci or with a free of hand. You can calculate these terms. It is a simple for calculation. After that we have fifth type, counting sample points. Is a tree diagram method. We will include it with the branches and trees, subnodes, vertices. Draw branches for each stage of the experiment. We will draw each stage with branches and useful for visualizing dependent event. It will help us to identify the events with the visualizing the drawing the tree structure. Example, tossing a coin. We have tossing a coin, then rolling a die. Two branches of a coin. We have two faces, coin, head and tail, and for dice we have 6. Multiplying these two terms, we will get 12. We will draw it in tree diagram method. Is known as a counting sample points concept. We will represent the terms with multiplying and representing in tree structure. Is known as a tree diagram method. Next concept, probability of an event. It is a process of calculating the probability which occurs in a specific event. It is a measure of how likely that event is to occur. It will measure the probability with the favorable outcomes by total possible outcomes. Probability definition. It is in simple words calculating the ratio with the favorable outcomes by total number of outcomes in the sample space. The probability range always lies between 0 and 1. Probability must be equal or less than 1. It is the range. For causing the coin, we have sample points, head and tail, two outcomes. Getting a head is a 1 probability or getting a tail is 1 probability. For representing, we will represent as calculating one favorable outcome by total number is sample space events. Outcomes 2, 1 by 2. Die rolling. We have 6 phases in rolling a die. For that event, we have event numbers 3, odd numbers also 3. By calculating total favorable is 6. In ratio format, we will represent with the favorable outcomes by total number of favorable outcomes. It will give us the solution as 1 by 2. Drawing a card. We have a total deck of cards 52. In that we are drawing the card king or queen. We have 4 cards favorable. For total outcome we have 52 cards. By calculating we will get 1 by 13.